In this lesson, we will use a short story to understand the mole as a unit of measurement. The Mole Mystery in Atom Village. In Kemia town, there was a village known as the Atom Village, where everything was made of atoms. The atoms were so small that no one could see them, not even with the best magnifying glass. The citizens of Atom Village were scientists. They were always trying to count how many atoms were in a grain of salt, a drop of water, or a puff of air. But there was a problem. Atoms were too small and too many to count one by one. It was like trying to count grains of sand on a beach. One day, a brilliant scientist named Professor Avogadro came up with a clever idea. He said, instead of counting atoms one by one, let us create a special unit that represents a huge number of atoms. We will call it a mole. Everyone in Atom Village was curious. How many atoms are in a mole? They asked. Professor Avogadro smiled and said, exactly 6.022 by 10 to the power of 23 particles. That is 602 sextillion 200 quintillion atoms. The scientists gasped. That was a giant number. But it made their work easier. Now, instead of saying, I have 602 sextillion atoms of oxygen, they could simply say, I have 1 mole of oxygen. Soon, the mole became the standard unit for counting atoms, molecules, and ions. It was used in science laboratories, classrooms, and even space missions. Whether measuring gases, solids, or liquids, the mole helped scientists understand how much of a substance they had. And so, the mole became the hero of chemistry, solving the mystery of counting the invisible, and making the world of atoms easier to explore. Here are the key learning points. Atoms are extremely small and numerous. Individual atoms are too tiny to count directly, making it difficult to measure substances at the atomic level. The mole is a counting unit for particles. Just like a pair means 2 items, a dozen means 12 items, and a gross means 144 items, a mole represents 6.022 by 10 to the power of 23 particles, that is, atoms, molecules, or ions. Avogadro's number defines the mole. The mole is based on Avogadro's number, which is 6.022 times 10 to the power of 23. This is a huge number that is used to count microscopic particles. The mole simplifies chemical calculations. Instead of dealing with massive numbers of atoms, scientists use the mole to make calculations manageable and meaningful. The mole applies to all substances. Whether you are measuring oxygen gas, water molecules, or sodium ions, the mole helps quantify how much of a substance is present. The mole connects mass and particles. Using the mole, scientists can relate the mass of a substance to the number of particles it contains.